A pleasant greetings to all. In this video, I am going to explain clock D flip-flop. Already in the previous videos, I have explained D flip-flop, SR flip-flop and JK flip-flop. That I have given in the description box. What is clock D flip-flop? A toggle flip-flop gets its name from the fact that the flip-flop has the ability to toggle or switch between its two different states, toggle state and the memory state. Since there are only two states, T-type flip-flop is ideal to use in frequency division and binary counter design. Binary ripple counters can be built using toggle or T-type flip-flops by connecting the output of one to the clock input of the next. Toggle flip-flops are ideal for building ripple counters as it toggles from one state to the next, high to low or low to high, at every clock cycle. So, simple frequency divider and ripple counter circuit can easily be constructed using standard T-type flip-flop circuit. Next, I am going to explain the logic symbol and the logic diagram for the clock T flip-flop. Okay, first of all, we are going to see the logic symbol. Only one input, that is T, clock pulse is given here, Q is the output and Q bar is the output. Next, I am going to explain the logic diagram for the T flip-flop. The T flip-flop, that is obtained from the JK flip-flop. It is similar to the JK flip-flop, only one difference, J and K are connected together, and in this point, input is given, that is T. Okay, 4 NAND gate is used here. Here J, K, and output of the NAND gate, the second NAND gate is connected to this, and output of this is connected to here, and clock is given between these two, that is clock pulse, and then here take one terminal, and this is connected here, and take one terminal from here, and this is connected to the second AND gate, and J and K connected together, and here T is given. This is the diagram of T flip-flop. This is Qn and Qn bar present state, and this is the next state Qn plus 1 and Qn plus 1 bar. Okay, this is the logic diagram for T flip-flop. Next, I am going to explain the truth table for the T flip-flop. So, first of all, consider the case number 1. Clock is high clock, then input T is equal to 0, present state Q1 equal to 0. Put T is equal to 0, clock equal to 1, and present state Q1 is 0. So, Q1 bar is 1, 0. Then here 1 is connected, and here 1, 0 is connected here, and here also 1 is connected. 0 into 1 into 1, that is 0, 0 bar is 1. Here also 0 bar, that is 1, 1 into 1, that is 0. So Qn plus 1 next state, that is 0, and the same 0 is connected here, and 0 into 1, 0, 0 bar is 1. Qn plus 1 bar, that is equal to 1. So there is no change in the state 0. And next I am going to consider the next condition, case number 2. In the case number 2, here this is changed. So for the case number 2, T is equal to 0, present state is equal to 1. Here present state is 1 now. And what is 1 bar? 1 bar equal to 0. So here 0 is connected here, and here 1 is connected. So 1 into 1 into 1, that is 1 bar equal to 0. Here 0 bar equal to 1. 0 into 1, 0 bar, that is equal to 1. And this 1 is connected here, here we get 0. So this is also, we get the same present state, there is no change in the state. And next I am going to explain the case number 3. So in a case number 3, here 0 and here 1. The case 3 is high clock, t is equal to 1, present state equal to 0. So clock is high, that is 1, and t is equal to 1. So t is equal to 1 means 1. Then here present state equal to 0, q bar equal to 1, 0 is connected here, 1 is connected here. So here 0 and 1. Now 1 is connected here, 0 into 1, that is 0 bar, that is equal to 1. Now this 1 is connected here, 1 into 1, that is 0. Okay, qn plus 1, qn plus 1. Now see here, the present state is 0, but we will get the next state as 1. And next we are going to consider the next case, case number 4. In a case number 4, t is equal to 1, clock equal to 1, and present state equal to 1, so 1 bar equal to 0. So the 0 is connected here, the 1 is connected here, 1, 1, all are 1. Okay, here 0, here 1, and 1 into 0, that value equal to 1. The same 1 is connected here, we'll get the value 0. Okay, so present state is 1, but we will get the next state as 0. Have to substitute the value here, and let's next consider the last case, case number 5. In a case number 5, the clock equal to 0 and t is equal to 0 and present state equal to 0. That we have considered. So clock equal to 0, t is equal to 0, present state 0, here 1. So 1 is connected here, so 0, 0 and 0 is connected. 1, 0, 0. Here 1 and 1. 1 into 1, that is 1 bar, 0. 0 into 1, 0 bar, 1. There is no change. So state is no change. Here toggles. Because the present state is 0, but next state is 1. Present state is 1, next state is 0, toggles. Here qn, there is no change. Next I am going to explain how to find out the function table from the truth table. To find out the function table, what we have to do, from the truth table only, we can find out the function table. See here, t is equal to 0, 0. But next state equal to present. There is no change in the present state. So how to write 0, qn. And next see here 1, 1. And here present state is 0, 1. The value is inverted here, toggles. So how to write 1 qn bar. So this is the way to write the function table. So after finishing the function table, what we have to do? We are going to find out the characteristic equation. So using the coordinate map, we can find out the characteristic equation. For finding out the characteristic equation is qn plus 1. How to find out? I am going to take t and qn only. Have to substitute the value here t, and this is qn. When t is equal to 0, qn equal to 0, qn plus 1 is 0. T is equal to 0, qn equal to 1, and then next state, that is 1. When t is equal to 1 and qn equal to 0, the value equal to 1, toggles. And t is equal to 1, qn equal to 1, the output qn plus 1 equal to 0. And see here, only one, we have to circle it because there is no neighboring cells, the same one, the neighboring cells. Now, so single one is circled here. What is the value? This is t into, this is t bar into qn, and this one is t into qn bar. So addition of both, we get qn plus 1, that is T bar Qn plus T Qn bar. This look like a XOR gate. So T XOR Qn. So this is the characteristic equation of the T flip-flop. After getting the characteristic equation, what we have to do? We have to find out the excitation table. How to write the excitation table? For finding out excitation table, first write Qn, then Qn plus 1. 0, 0, 1, 1, 0, 1, 0, 1. So first 0, 0. Here 0, 0. What is corresponding value of 0? That is equal to 0. So I have to mark this. And next 0, 1. 0, 1. What is the corresponding value of t? That is 1. And next 1, 0. What is the corresponding value of t? That is 1. Next see 1, 1. What is the corresponding value of t? That is equal to 0. This is the excitation table. After getting the excitation table, directly draw the state diagram. State diagram is drawn from the excitation table. Okay. See, first of all, this is the present state. 0 is the present state and 1 is the present state. From this, 0 to 0, here 0, 1 to 1. So 0 to 0, t is equal to 0. 1 to 1, t is equal to 0. Okay, in both the cases, t is equal to 0. And then t is equal to 1, the present state is changed to a next state. Present state 0 is changed to a next state 1. Toggle t is equal to 1. And then t is equal to 1, the same t is equal to 1. Present state 1 is changed to a next state 0. Then at that time also t is equal to 1. So this is the state diagram for the T flip-flop. Thank you. Have a nice day.